Hello everybody, this is Professor Jang of Bugyeong National University. Today I will talk about electrocardiogram. So it is often called ECG or EKG. So what is it then? So this is a very introduction of the ECG. So today I will talk about what the ECG is and how it is generated and how we can measure ECG and how we can make a computer program or software to understand ECG automatically. Okay, so heart is a muscular organ which pumps blood through the blood vessels of the circulatory system, right? So our blood are coming from our hearts and move to our bodies, and then it come back to our hearts. So it continuously moves, right? Without our hearts, it cannot move. So it's our hearts works like a pump. So let's see one video. So you can see it is moving. See, it's pumping the blood continuously, so sending the blood small by small. Okay, then this movement of heart is periodic and autonomous movement. So which means it moves continuously. And it cannot stop until we die, or we are about to die and it stops. Or so if we have some disease, then it does not move regularly, then we need to take some medicine or we need to get some surgery. Okay, so this is what we are calling periodic and autonomous movements. And this movement generates electrical signals. So this signal is what we are interested in and we are talking about in this class. Okay, let's move to the next slide. Electrocardiogram is a combination of three words. So electro, it means electric, right? Electro something, and then electricity is the electricity, and then this is basically we are talking about electric. And the cardiogram, so we say we are calling cardio, and this means the heart of the heart, and this is the heart, and this is the last one. That's part of this terminology is gram. This gram means the records. So when we say electrocardiogram, this means electric heart records. So records of electric activity of the heart. Okay, and probably you see the ECG signal many times in soft drama. So when you are watching Netflix or TV series, then you can see especially when the program is about the hospital, then you can see some patients laying on the bed, and then there's some pretty complex system on the patient, and this kind of signal is continuously moving, and then this denotes that this person is alive. When the patient dead, then this signal is continuously moving, and then this signal stops moving. Then we say that this person is passed away. Okay, so this ECG is the measurement of potential changes occurring due to heart movement from the outside. So this ECG is recorded from the outside of the body, right? We cannot record the ECG inside of the body, but we can record the outside of the body, and then this signal is reflected. This signal reflects the movement of our hearts. So this is the ECG. This ECG can be used in many applications. For example, basically this is used to monitor the patient's heart. So especially a person is in a dangerous situation, then we can continuously monitor the patients using the ECG, and whether we are continuously checking whether heart is working well or not. Because our heart stops, then person is going to be die in a few minutes. So this is a very important signal for human or any other animals as well. And also we can measure some stress or tensions of our body. So we can analyze this signal, heart movements and heart signals, and this signal has a pattern. And then when it patterns, I will explain about these patterns later. And this pattern changes. There are regular patterns and irregular patterns. When it becomes irregular, then we can assume that there is some problem in our hearts. And usually we have the smartwatch, and which can measure ECG, and then this is so we can measure the mobile device. This is not very accurate to compare to the ECG device in the hospital, but still we can record the ECG. And also we can use this for the people who works in very in dangerous situations. For example, soldiers or firefighters, and they are working in very hard conditions. So sometimes maybe it's necessary to monitor their health status continuously. For example, a firefighter is working in the spot, and then sometimes he may be injured, then or his tension or his stress increases a lot dynamically. Then we may call another person to help the person who are in danger. Okay, so also we can check the we can recognize emotional changes using ECG as well. Like if you are falling in love and you are watching a person who you love, then your ECG, your heartbeat is going to be changed, of course. Okay. And the second topic of today is how it is generated. So this image is the inside of our heart. So there is an organ called the sinus node. So at this spot, the signal starts, the heart signal starts. And this organ, the sinus node, continuously generates the signal for our heartbeat, and continuously and regularly, periodically. And understand? So this gives the signal regularly, beep, 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 beep. This sinus node generates this signal, and our heart beats, moves according to this signal from the sinus. This generated signal at sinus is transmitted to the other parts of our hearts, especially muscular parts, to the muscles of our hearts. So it starts at the sinus and it transmitted to here, and then here, and following the nervous system of our hearts. And when our heart muscles receive this signal, and it starts to move. And when it moves, the electric signals are generated from our muscles. So this is called depolarization. So you see here the terminology here, depolarization. And this depolarization means that our body is electrically stable states when we do not move. When we do not move, at all, then electric charges are stable and does not change much. And if it does not change, that we can say there is no signal. Okay, so it's very stable. But with some problem or some issues, then these electric charges are changing, and maybe some part of our body has more electric charge, and then some part of our body is less electric charge. So if we have more electric charge of minus, then that is minus, and then relatively if some part has a less electric charge, this is going to be plus, and then this is stable anyway. And if our body, especially our body muscles, are starting to move, then at that point the electric charges are moving, starting to move, and this movement generates electric signal. Because electric charge changes, the position of electric charges, the amount of electric charges changes, then the electric potentials is going to be changed, right? And then the signal changes, the signal occurs. So this is how we can measure our muscle movements, especially over here, how we can measure our heart's movements. You see there are lots of signals here. When sinus nodes generate the signal, and this signal is pretty small here, you see, but when it starting to stimulate the muscles, then you see the muscle signals here, arterial muscle here signal, and AV node signal here, and you see the signals occurs gradually, so shifted. So at first SA node signal occurs, and then arterial muscle signal happens, and then AV node signal occurs. So signal transmitted from SA node to the other parts of our hearts. So it's a reaction, our muscles reaction time is going to be different according to the position. And finally, the action potentials occurs at the bottom of our hearts, and then the signal finishes. Then when we accumulate all the signals occurs in our hearts, then the signal is going to be like this: small arise, and then go down and up sharply, and decrease sharply, decrease sharply, and then go up, and then there is another wave here, small wave. So we call this is PQRST wave, and this is a very significant wave shape of our ECG. And this is our ECG has this kind of shape because we measure our ECG from our outside of our body, not on the heart. If you measure ECG on our on our heart directly, then ECG signal is like this, just like this. So we can measure lots of waves, separated waves. But instead of that, we measure ECG from our outside of our body. Then the measured signal is going to be like this. Okay, so this is very general shape and very significant shape of ECG, but this shape differs person by person. So some person, and also like according to the states of the person, then this shape is going to be different. So using this shape, then we can estimate the states of the person So maybe we can say, oh, okay, this person has a heart with disease, this kind of disease. Okay, this kind of disease. And this ECG actually is the combination and is composed from the lots of separated signal of our hearts. Then using this signal, the composed signal, from this composed signal, we can estimate which part of our hearts generates a strange signal. Can you understand? Okay. Right. Yes. Then we want to measure the heart movement. So actually, if it is possible, then we want to put the lots of electrodes on our hearts directly. Then we can measure our heart movement very, very precisely. But it is difficult and almost impossible. So instead, we are going to record the heart's movement from the outside of our body. Okay, then to measure ECG, so in this image you can see what happens when we are recording ECG. So this person is has lots of electrodes on his chest and some electrodes on the arms and legs, and there is an ECG machine here, and then we can see the recorded ECG. And to do this, we need to know the electrodes, okay, where we are going to put it, and we need to know the amplifier and the electrode placement and the processing. So electrode is the thing which we are going to put on our body. And you see this person, you see, and also you can see the person in the left bottom, and we can put 10 electrodes on the body of the body, and then from these electrodes we can get the signal. So if we don't put the electrodes on our body, then it's difficult, right? And also we need a kind of paste to get the signal without noise. So because we want to get the electric signal from our body, so electric signal should be transmitted without noise. So if there are, because our skins resist, basically our skins try to resist the electrodes, transmitting electrodes. So it is very important to make the electrodes passes from our body to the electrodes and amplifier. So this electrode is connected to the amplifier. Amplifiers are necessary because our ECG signal, our body signals are very weak, and this is used to magnitude, make it bigger, because the measured signal is a millivolt unit. And then after that, we need computing power to process it and to recognize it if it's necessary. And if you go to a hospital to measure ECG, then the doctors will put 10 electrodes on your body. So left and right arms and left and right legs, and 6 electrodes around your heart. This is necessary because we want to record the 3D movements of our hearts. To measure electric potential, it's the same for ECG and EEG and EMG and EOG. It's all the same. we need at least 2 electrodes. Okay, one is baseline and the other is where we want to measure it. So we can measure the electric potential between the 2 spots. Otherwise, it's very difficult to get the change of the electric charges. Okay, and I told you that we need at least 2 electrodes. So we can make pairs like a left arm and a right arm. So simply we just substitute the right arm signal from left arm signal, and then we just say LA minus RA. Okay, and then we get this kind of signal. And also we can get LL minus RA, LL minus RA, right arm, substitute to our right arm signal from left leg signal, and then this kind of signal we can get it. So using this way we can get the 3D movements. Okay, there is one heart here, and we can measure in this way and that way, this way and this way, and then we can see this lots of signals, and we can estimate and predict the states of our hearts. This is called 12 lead measurement. So this is the most basic measurement method, and we get 12 signals using 10 electrodes. So this is the fundamental way of recording ECG, but if your purpose is not to estimate some heart disease or something very precisely, then we can get ECG using only 2 spots from 2 electrodes. Yes, so you know that our smartwatches can measure ECG. So this is Apple Watch, and I have Samsung watches. And to measure ECG using the smartwatch, then you need 2 electrodes, one in your left arm and the other in your right arm. Then you wonder, oh, I have only one watch, it's not the left arm or right arm. Okay, then to measure ECG, you probably are going to put your right finger to your left arms like this. Then this device will measure 2 spots, one in your left and the other from your right side, and then we can briefly measure the ECG. If we don't use the 2 electrodes, we cannot get the ECG signal, but instead we can get PPG signal, or we can get BPM directly from the PPG. So our heart beats. That is possible, but it is not possible to get the ECG. And this is we are almost at the last part. So let's check how can computer understand the ECG. Okay, so we measured the ECG. So we studied that what is ECG and how we can measure it and how it is generated. Then now how we can make a software to understand the ECG. Okay, right. In these days, just we say, oh, I can use deep learning. Yes, right. It is true. But let me say some details. So this is the ECG signal. I downloaded data from this website and then put the ECG. Okay, you can see the signal of PQRST here, and it is repeated. And you see there are some intervals between this peak. We say this is RR interval. So this peak, highest peak, is called R peak. So we say the intervals are RR interval. These intervals are not equal, and it changes, it varies. But it should be similar. It should be similar, not so different. And if it is if it changes, maybe the standard deviation of these differences are too big, then it's a problem. Or if the intervals are exactly the same, then it's another problem. Okay, then anyway, so that is one feature, and the other features are from the shape of this PQRST wave. So we can, to understand that the signals and to make the model, AI models not run these patterns, then we may separate these signals one by one, and then we can accumulate, or we can draw in one figure. Then we can see they are very similar but slightly different. Okay, so from this shape we can understand, we can estimate the digits of our hearts. So because so first step could be, so in these days, yeah, of course we are using deep learning techniques, so sometimes we just put the all signals all together, so it is possible, but we cannot put whole signal into the deep learning model. This is too long. So usually we separate the signal small by small. So here just for example, I divided the signal patterns one by one, okay, and extract it, and then draw it in one float. Okay, then this is one way to process before using the deep learning model. And after that, we can extract some features from this signal. So like amplitude, wavelength, frequency, power, and etc. And those features are extracted from the pre-processed signals. And yeah, as I told you, then some recent studies often ignore this feature extraction and just use the raw signal directly. And after that, the last process is going to be the pattern recognition. And if we want to use traditional machine learning models like SVM or ANN, logistic regressions, and then probably you will need the features. This is still effective, especially when your data, number of your data are limited. But if you have a lot of data, then you can use the deep learning directly. And when you are using deep learning technique, then we can use the one-dimensional convolution and LSTM, long short-term memories, and attentions and transformer and etc. There are so many models we can use it, and there are so many layers as well we can use it. And in these days, deep learning is the best popular. So this is not the deep learning class, so I do not want to explain the detail of the models. So maybe you may find another lecture of me or somewhere else. Okay, this is going to be the summary of our today's lesson. So today I talked about the ECG, and I talked about what the ECG is, and then I explained how ECG is generated and how we can measure the EEG and how the computer can understand the ECG. So just I emphasized the first two parts, and then the last part was not much emphasized and just explained briefly. So because the deep learning part is so big, and if I starting to explain about deep learning, then it's going to take too much time. So I just briefly explained. Maybe if I have some time, more time, then I will explain about deep learning models later. Deep learning model structures and how to build it, how to adjust it. Okay, So thank you for your attention, and I want to close my lecture about ECG here. Thank you.